In this nugget, you and I get to walk through the solution for troubleshooting ticket number 11. Let's begin. So for this nugget, PC1 right here is going out to the internet server, and it says it is 7 hops away, and it should always be 6. So I guess the first thing we should do is maybe do a baseline just to verify that we do have connectivity, and then secondly, we'll verify that we currently have 7 hops, and then we'll start troubleshooting from there. We will begin here on DSW1. We're going to bounce the interface VLAN 10 just to rule out that it's causing us any additional problems above and beyond what we're troubleshooting in this nugget. And then we'll go ahead and bring it back up, and then we'll make a road trip over to PC number 1. Here on PC number 1, let's get an IP address using IP space DHCP. And it's always exciting to see whether or not that O is going to show up after the discover. Looks like it did. And we have an IP address and a default gateway. That's great. Next, let's verify basic connectivity out to our internet web server at 209.65.200.241. We'll do that with a ping. Looks like that's working. So next, let's do a trace route out to 209.65.200.241. And what we'll do is we'll count the hops. And I typed in traceroute. So traceroute is a fantastic command if you're on an iOS device. And we're on a virtual PC simulator, so the command is simply trace. So we'll put in the correct command of trace 209.65.200.241, and that will count the hops in the path. And sure enough, we have 7 hops. So let's map out together the devices that these are in the path. And as you already know, it is really handy to have that topology available so you can refer to it whenever you need to. So our first hop is 10.2.1.1, and that is the VLAN 10 interface address of DSW1. So we're using .254 as a default gateway. DSW1 is the active router for that group, and so when we started sending our TTLs with a time to live of 1, the first device in the path that killed those packets and sent us a message saying, hey, the TTL expired, was DSW1, and he sourced that ICMP message coming back to us from his VLAN 10 interface that has 10.2.1.1, and that's why we see it right here. So the first hop is DSW1, and then the next hop is 192.168.1.130. And if we look at our table, that IP address is DSW2's VLAN 200 interface. And then it went to 10.1.4.9, which is R4's interface, and then it continued out the path out to the internet. So let's take a look at our topology and actually consider this hop of .130. So let's take a look at the path involved. PC1 sent it over to DSW1 for the first hop. DSW1 sent it over to DSW2. So if all of these trunks are carrying VLAN 200, the path could have gone this way and then over, or it could have gone down to ASW1 and over, assuming that VLAN 200 is present on both access layer switches and VLAN 200 is being forwarded on all the trunks. In either case, that was the second hop of 192.168.1.130. And then it went to R4, and then it went through the rest of the path over to the internet. So the question I really have is, why did DSW1 route it over to DSW2 as the next hop instead of just going directly to R4 itself? That, my friend, is what I think our fault domain is right here. So what I think we should do is go have a chat with DSW1, and on DSW1, we'll take a look at its routing table regarding default routes and or a route to get to 209.65.200.241. So here on distribution switch number 1, let's use the command show IP route and see what he's thinking. And he's thinking about quite a bit. Look at that. We've got 3 routes to get to the 10.1.18 network. We've got 3 routes to get to the 10.1.48 network. And we've got 3 routes to get to the 10.1.4.4 network. And we also have 3 routes that we can use for our default route. So one of the problems I see right off the bat is this guy right here. This route to 10.1.4.4, we should be directly connected to that network. We should not have learned that from EIGRP and placed that in the routing table, because it should be a directly connected route that should show up in the routing table. So let's thin the playing field a little bit, and let's do a show IP route connected to see just the directly connected routes. And sure enough, DSW1 does not have a directly connected route for 10.1.4.4. And that's the network, or it should be the network, between DSW1 and R4. So maybe we have an interface that's misconfigured here on DSW1, for example, with a completely different IP address. Or we could have an interface that's down. That would also cause a route not to show up as a directly connected network if the interface is down. So let's do a show IP interface brief, and we'll do a pipe and say, please exclude any output that has the word unassigned in it. That way we don't have to look through all of the layer 2 switch ports on this multi-layer switch. And let's take a look at these interfaces, and there we go. Look at that. FA00 indeed is down doobie doo down down. Administratively, that is. So that explains a couple of things. Number one, it explains why the directly connected network of 10.1.4.4/30 is not showing up as a directly connected route because FA00 is down on DSW1. It also helps us understand why DSW1 forwarded a packet destined to the internet, because if we scroll up just a little bit and we take a look at our default routes, we have 3 of them, and the next hop for each of those 3 is DSW2. So in the question it said that the number of hops for PC1 to get to the internet should always be 6. But we could argue, well, because FA00 is down on DSW1, we had to forward it to our good buddy DSW2 to get to the final destination. But if it said that the hops should always be 6, perhaps they're implying that even if there's a failure, we should still have 6 hops. So one of the solutions we could implement would be to just bring up FA00 here on DSW1. However, in the future, if that interface goes down or that network is no longer available, so what we could do is we could do some tracking in HSRP so that if, for example, FA0/0 goes down on DSW1, we could reduce the priority of DSW1 for the VLAN 10 HSRP group. And then if DSW2 has preempt enabled for the VLAN 10 HSRP group number 10, then DSW2 could take over and be the active router, and we would be right back at 6 hops. Because then DSW2 would be acting as the default gateway for VLAN 10. So let's take a look at what's currently configured. We'll do a show standby VLAN 10. This is on DSW1, and DSW1 says, hey, I'm active for this group. There's the IP address I'm supporting, and the standby router is at 10.2.1.2, and the standby router's priority is 100. And here it's talking about DSW1's own priority, which is 109. Now look at this. It says that the configured priority for DSW1 for this HSRP group is 115, but it's currently at 109. And then down below it says, oh, we have track object number 5, and that tracked object is currently down, and as a result, we're decrementing 6. So 115 minus 6 would be 109. Because the peer, DSW2, is currently at priority 100, and we got bumped down to 109, DSW1 still has a higher priority than DSW2. So if the objective was that this tracked object, if it's down, should make DSW1 no longer the active router for this HSRP group 10, we have 3 options to accomplish that. Number 1, we could go ahead and configure the priority on this router to be lower to begin with. Or we could make the decrement larger if the tracked object is down. And the third option is we could make DSW2 higher as far as its priority. And any one of those options, if we tweak it correctly, could cause DSW2 to go active for HSRP group 10 in the event the tracked object is down. So a good question to ask is, what exactly is being tracked by this track object 5? Let's do a show track and take a look. So show track shows us that track 5 is looking after interface FA00. It's looking at the line protocol, and at the moment the line protocol is down. It's also telling us right here that not only is it down, it's also being used by HSRP group 10, which is why we have the decrement of 6 against our configured priority of 115, ending up in a current working priority of 109. So if we do a show run for interface VLAN 10, we can see how it's administratively configured. So here's our priority of 115, and here's our tracking statement with the decrement in the event that tracked object is down. Now let's also do a show standby for VLAN 20 right here on DSW1. So DSW1 says, okay, regarding VLAN 20, I'm the standby. The active router is my good buddy DSW2, who has the priority of 105. So in our topology, if the desire is that DSW1 is the active router for VLAN 10 HSRP group 10, and that DSW2 by default is the active router for HSRP group 20, which is supporting VLAN 20, that is how these devices are configured. Now the problem is that if DSW1's FA00 fails, they're only decrementing his priority by 6. And that priority is still higher than the default priority that DSW2 has for HSRP group 10. So one other thing we had to do is this. If we just set the priority for DSW1 for HSRP group 10 to 105 instead of 115, then because the tracking is happening, If the tracked object is down and we minus 6, that'll put us at 99. And as a result of being at 99, DSW2, with the priority of 100 and preempt enabled, will take over the role, the active role, for HSRP group 10. And as a result, when the PC sends traffic, it'll be handled by DSW2 to begin with, and then routed out to the internet, and we should be back at 6 hops. So here on DSW1, let's go into configuration mode and into interface VLAN 10. Let's change the administratively configured priority to 105 with the command standby 10 priority 105. We'll exit out of interface configuration mode, and what should happen is we should have a message indicating that we are stepping out of the active role and into the standby role. And if we went over to DSW2, we should see a message there on DSW2 indicating that DSW2 has now gone active for HSRP group 10. And from right here, if we do a show standby VLAN 10, from DSW1's position, he says, okay, I'm standby, I get it. My current priority is 99, I'm configured as 105, but my tracked object is down. And as a result, there was a decrement of 6 for my priority. And DSW2, he had a priority of 100. He also had preempt configured, and as a result, he took over the responsibility for the active router for HSRP group 10. So if we go up to PC1, and here on PC1, let's do a ping of 209.65.200.241. I'd just like to verify that we have connectivity, and then we'll hit the up arrow key a couple of times, and we'll do a trace out to that same destination, and we're hoping for 6 hops. And that's because the first hop is now 10.2.1.2, which is the interface IP address of DSW2 on VLAN 10. And that's because DSW2 is now the active router for our HSRP standby group 10. Now, there's one more aspect I would like us to check, and that is, what if we go back to DSW1, let's do that right now, and on DSW1, what if we brought up the interface FA00, which is currently down? What should happen is, we will no longer be decremented 6, our priority will be higher than DSW2's for HSRP group 10, and because we have preempt enabled, we should take back over the role of the active router for HSRP group number 10. So let's do it. We'll go into interface FA00, we'll do a no shutdown, we'll exit out of configuration mode, and there we have a message that we just went active for VLAN 10's HSRP group 10. So now if we go back to that same PC, and on the PC we'll just use the up arrow key and do the trace one more time, our first hop is now 10.2.1.1, which is DSW1's IP address because DSW1 is now acting as the active router for HSRP group number 10, and effectively, it's the default gateway that PC1 is now using. So for troubleshooting ticket number 11, the fault domain was DSW1, the technology was HSRP, and the solution was to adjust the priority so that if the tracked object did fail or did go down, the resulting priority on DSW1 would be below the priority on DSW2, who could then go active and be the default gateway for HSRP group number 10. I am glad that you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.